Hello everybody. Today I'm going to release the new project I'm going to hold on my channel, which is basically the problem of the day. Basically, at the beginning of each day, I'm going to post the most interesting problem the people in my Discord server have suggested, and at the end of each day, I'm going to make a video editorial based on that problem. In order to be able to suggest problems or solve them in advance, you should join the Discord server in the description. Now let's move on to the problem of the first day. The problem I've chosen for today is a Romanian problem, of which I'm the author, and I used this problem at my school's Olympiad. Basically, we are given a graph of n vertices and m edges which is not connected, and we need to find the answer to two questions. First question is the minimum number of edges we must add in order to make the graph connected, which is basically the number of connected components minus 1. And the second requirement is if we define the cost of adding an edge between A and B as A plus B, which is the minimum cost of edges we must add in order to make the graph connected. We are given the graph and either 1 or 2, which means that we should solve only the first or the second requirement. And I'm going to present the solution, which turns out to be a quite interesting one. Basically, we must find the connected components. This can be done quite easily using DFS. And also, we must find the minimum value for each connected component. This can also be done while doing DFS. Now I'm going to make two claims which will help us get the answer for the second requirement. The first claim is that if we connect two connected components, we must always connect the smallest values from each connected component. This is quite easy to find because if we connect a bigger vertex, a bigger valued vertex, then we are going to have a bigger cost, which is not optimal. And the second claim I'm going to make is that we must always connect the connected components to node 1. This isn't too hard to see either, and the main reason why we should do this is because vertex 1 is the smallest numbered vertex, and the costs will be always smallest. Also, we are not restricted in any way when it comes to connecting the graph, so we must always connect the nodes to 1. Now I'm going to show how I'm going to draw the edges. Basically, an edge between 1 and 3, and an edge between 1 and 5. The cost of each edge will be 4, respectively 6, according to the definition from the statement. Now let's move on to implementing this solution. As you can see here, I read the input. The problem requires a file input, but you can solve it with standard input. But in order to be able to get 100 on the judge, you must submit it with file input. And we are going to run DFS for each connected component to find the minimum values. DFS is quite easy to write, but because n is quite big, you need to use vector from C++ in order to keep the neighbor list. Now I'm going to sort the values of the neighbors, even though that's not needed, since according to my implementation, they will always be returned in increasing order. But I sorted them just in case. And last but not least, I'm going to implement the following claims I've stated in the description of the solution. Basically, for each connected component, we are going to connect it to vertex 1, and we are going to add the cost as follows. Last but not least, we will print the cost based on the requirement. If you enjoyed watching this video and you would want to see more content from me, please like the video, subscribe to the channel and press the bell button. Also, if you want to join the Problem of the Day project, please join my Discord server. Until the next time, stay healthy, stay safe, good luck and goodbye.